Hi class, it's Professor Rourke here. I wanted to make a video because I had a few questions asked my instructors from this particular question. So I figured it would be a good one to make a video about, and that way you can check it out if you're having issues with it. This is question number 15. So it's the last question in the homework that is due today. Actually, it's combines together 1.6 and 11.1. So 1.6 was introducing like the different vocabulary from experiments, and then 11.1 is where we're actually going to be trying to do hypothesis testing involving the proportions. So two different proportions. So let's take a look at number 15. Also, this has a little asterisk here, which means it's from another textbook. So occasionally that means that usually gives me a little clue that they could possibly use slightly different vocabulary, which can make it extra tricky. But let's just read this problem and take a look and see if we can identify the issues that are causing some difficulty. Okay, so this problem says a simple random sample of front seat occupants involved in car crashes is obtained. Among the 2,917 occupants not wearing seatbelts, 28 were killed. Among the 7,624 occupants wearing seatbelts, 12 were killed. Use a zero point 0.01 significance level to test the claim that seatbelts are effective in reducing fatalities. Complete parts A through C below. So these questions have a lot of information in them, just right off the bat. And also, it can be difficult to sort of break down, to label which group is what, because that's going to affect how we have to write our null and alternative hypothesis, right? So let's read part A. It says, test the claim using a hypothesis test. Consider the first sample to be the sample of occupants not wearing seatbelts, okay? And the second sample to be the sample of occupants wearing seatbelts. What are the null and alternative hypothesis? Okay, so what that means is that the P1, the proportion for the first group, is going to be the ones not wearing seatbelts. So it's going to be the proportion of people killed not wearing a seatbelt. Okay, and I just want to make sure we like jot that down because this is all the stuff that we have to think through in these problems. So it's the proportion of people killed who were not wearing a seatbelt, right? Okay, it's very large writing, so I'll probably have to erase this after we answer this question, but that's okay. And then they say, again, the second sample to be the sample of occupants wearing a seatbelt. Okay, so that means P2 would be the proportion of people killed, right? Again, I know it's always sometimes these problems are very depressing, but it's the portion of people killed wearing a seatbelt. Okay, so that there can just be difficult to sort of get down. Okay, so I recommend, especially for these problems where there's two proportions, or in terms of the next section, two means, we clearly label what we're talking about so that we can correctly get the alternative hypothesis. Okay. So, and again, they're trying to test the claim that seatbelts are effective in reducing fatalities. Okay, so that would mean, again, we have to sort of break that down. That would mean that the proportion of people killed wearing a seatbelt should be less than the proportion of people killed not wearing a seatbelt, right? Because hopefully less people die when they're wearing a seatbelt, right? However, this is the case sort of similar to the other day where P1 is the group that they just picked to be the ones not wearing a seatbelt. Okay, so when we're writing these inequalities, we know that we're trying to say that the proportion of people wearing a seatbelt should be less, right? We want less people to die when they're wearing theirs. We're looking to see if less people die when they're wearing their seatbelts, right? But because the first group is actually people not wearing a seatbelt, how we're going to need to write this is that P1 is greater than P2 because the proportion of people killed not wearing a seatbelt, we're trying to see if it's greater than the proportion of people killed when wearing a seatbelt. Okay, so sometimes it's like I just want to make sure we get it all down that we're looking to really see again the seatbelts are effective in reducing fatalities. So because they told us to label these groups this way, what we're really trying to prove to see is if the proportion of people wearing seatbelts, P2, is less than P1. However, they're not going to write it like that. That's not going to be one of the options we have here because they're going to have P1 listed first. So P2 being less than P1 is really the exact same thing as saying P1 is greater than P2. Okay, so taking a look at these options here, what are the null and alternative hypothesis? The null is always going to start out with that equal to. We're just going to assume that they're the same. So we know it can't be A, we know it can't be B, and we know it can't be C because those all have the null hypothesis with wacky stuff. We always want that to be equal to. Okay, so it's either D, E, or F. And again, because we have to be careful to make sure we first read like, what are they trying to prove? And then which group is labeled with the first and which one's the second, we're actually going to select D, that P1, portion of people not wearing a seatbelt who die, is greater than the proportion of people who die when they're wearing a seatbelt. Okay, so that alone can be a lot just to kind of take care of. And then they want us to go ahead and use StatCrunch to find the test statistic. So let's go ahead and open up StatCrunch now. And what we're going to do is we're going to need to enter in both of the pieces of information here for group 1 and group 2. Okay, so we're going to do stat, and then we're going to go ahead and do proportion stats, right? Because this is talking about 2 proportions. And then we have 2 samples, and this is with summary. Okay, so sample 1, again, is the people who were not wearing a seatbelt. So the number of people killed is 28. Okay, sorry, I had to pause and then continue. Okay, so the number of successes is actually the number of people killed. So we're going to put 28 because that is the number of people that were killed out of the statistic that we're looking for out of the 2,917. That's sample 1. Those are the people not wearing a seatbelt. Then we go back and get the information for the number of people who were wearing seatbelts. That was 12 people who died, who were wearing a seatbelt, and 7,624 out of like the sample size of 7,624. Okay, and now we set our hypothesis test. We have P1 minus P2 equals 0, and P1 minus P2, this should be greater than 0. That's how the same exact thing that we wrote there, we selected for D. It's just that it's set equal to 0. So same thing. And then we can go on over here and take a look at the Z-stat. So the Z-stat is way off over here. It's 5 point, it's around 2 decimal places. So that would actually be 5.9. This 9 would get bumped up to like a 10 essentially, which would bump up this 9 to a 10, which actually turns our test statistic into 6.00. So if you think about our normal curve, right, with our z-scores on it, a z-score of 6 is way off the charts, right? That's way off to the right-hand side. And so that is why our p-value is so small. It says to round to 3 decimal places. Well, that would just be 0.000. Okay, so that is really like the smallest possible p-value we could get. I mean, it could be a little smaller, but it's very small. Okay, so what is the conclusion based off of this? So the p-value is less than the significance level of alpha equals 0.01. So we remember if the p-value is low, we reject the null hypothesis. So we reject the null hypothesis. So there is sufficient evidence to support the claim that the fatality rate is higher for those not wearing seatbelts. Okay. Now the last question here is sort of similar to how they introduced hypothesis testing with one proportion or one mean. They also sometimes have you do the same thing, but using a confidence interval. So thankfully, it's all in the same section in StatCrunch, so we don't have to do too much different. What I'm going to go ahead and do is I'm going to click Options, Edit, okay, and then I'm going to change it to the confidence interval down here. Now, the only slight issue is that we have to select the level for the confidence interval. And for most of the problems that they ask you for the confidence intervals, they'll tell you what level of confidence they want you to use, but they don't do that here, right? And I think it's again because it's from another textbook, so I can show you how we can do that. Okay, so it's made this a little bit bigger. So again, this is because it's from another textbook, but it's not terrible to sort of work through in terms of what level of confidence we're supposed to be looking for. Okay, so they told us in the beginning that we have this 0.01 significance level. That means that we are looking for this tail to have less than a 1% chance, really, right? Okay, 0.01 is 1%, which in terms of our normal curve that we've been using, we're looking for this confidence interval in between here. That's what we're going to be asked to find. So it makes sense that if we have a right tail of 0.01, we have a left tail of 0.01. That's like 1% on the right and 1% on the left. So we take the 0.01, we think about it in terms of a percent, which is 1%, 1%. And so the confidence interval that we're looking for would be a 98% confidence interval. Okay, so this would be different. Like if this was a 0.05 significance level, that would be like 5% on the right and then 5% on the left, and it would be like a 90% confidence interval. Okay, those are kind of like the big ones. But since they told us again that before, it all has to do with that 0.01 significance level, that means we have significance level means like the cutoff. We're looking for alpha to be less than 0.01. That means this tail is 0.01, which means, because the normal curve is symmetric, we'd have 0.01 curve on the left-hand side, and then we're looking for the confidence interval of a 98% in the middle. Okay, so I hope that makes sense. But let's go ahead and go back to StatCrunch and type this in. Now, again, this is because I think there's another textbook, and our textbook a lot of times will tell us exactly which confidence interval to use. They just kind of asked us to go a step beyond and actually just use the significance level to find the confidence interval ourselves. So it isn't awful, but so a lot of times they will actually give you the confidence interval that they're looking for, the confidence level. Okay, so let's see. If I go ahead and say the appropriate confidence interval is 0.004 to 0.012. If we found the different confidence interval of the difference of these proportions, and then let's see about what this actually is going to mean for us. Okay, whenever there's more than one drop-down menu, that's always fun. But it says because the confidence interval limits, it does not include zero, right? Because it's like from 0.004 to 0.012. If they were equal or close enough to equal for what we're looking for, it should include zero, right? Like if we subtracted two numbers together and they're close, it should be close to zero, like 2 minus 2.1 is close to zero, or 3 minus 2.9, close to zero, right? But these do not include zero. It appears the two fatality rates are not equal because the confidence intervals include only positive values. It appears the fatality rate is higher for those not wearing seatbelts. So this one, I feel like this interpretation one's a little easier than the one we had the other day, where it was just kind of annoying because out of 1,000 people, and they were looking for like a right tail test there. But what do the results suggest about the effectiveness of seatbelts? The results suggest that the use of seatbelts is associated with the same fatality rates of not using seatbelts. No. The results suggest that the use of seatbelts is associated with higher fatality rates than not using seatbelts. No. And now these also can be extra tricky because they kind of reverse the way we've been talking about it. We're talking about how P1 is not wearing seatbelts and P2 is wearing seatbelts. So we did find that P1 was greater than P2, but now they have it reversed because they're talking about the use of seatbelts is actually, the proportion is less than those not using seatbelts. So those are like extra tricky because it's so like detailed in terms of you have to be super careful about like, okay, which group are they talking about and like which group is labeled for what. And then even when they explain it, sometimes they like kind of mix them up. So those are really good one to look at. Hopefully this is helpful. Again, this was 15 from 1.6 and 11.1. That is your homework for that is due today on Monday. And then tomorrow is the last new section, which is 11.3 and 11.3A, which we'll tackle in class. And then next time we meet, we'll be reviewing for the final, which is crazy on Thursday. Okay, thanks class. Keep me posted for sure with any questions you have. Thanks.